What's up, everybody? Welcome back. Today we are working on generating a procedurally generated vacuum hose using software rendering with low dependencies. So, the context for this is we are working on this like Rube Goldberg machine thing. The idea here is that each of these boxes that you're seeing on the screen are custom defined by a WebAssembly module that is completely in control of like the physics and rendering in the chamber. The idea is that the users will be able to write their own chambers and upload them, and we can add them to the simulation and have like extremely custom behavior, and hopefully eventually build something kind of interesting. And today I want to work on the idea of a chamber who has a vacuum cleaner inside him. Maybe like he's got like a little vacuum, like one of those like tub vacuums, and he's like got some wheels on him, and the balls will kind of like fall into the chamber, and maybe we'll have like high friction on the floor, so the balls will kind of like stick like they would to a carpet, right? If you threw a ball onto a carpet, they don't really roll that far, so they'll kind of like end up kind of like sticking to the ground or whatever, and they'll be like scattered around. Now, what I want to do is I want to have this vacuum roll around and like vacuum up the balls. And so he's gonna have some sort of like hose that like comes here and automatically kind of figures out how to like orient himself towards the ball. I drew it a little small, so it's kind of hard to draw what I'm trying to draw here. Let's zoom in a little bit here, right? And just from like drawing this, you like notice a couple interesting things, right? One is that this is like a very curved surface, and so we added the ability to like render Bezier curves the other day, and these hoses, I think it looks a little better if they have like kind of like lines like this, right? Because like they're kind of like accordioned in real life, and like I think that it'll look better if we have this on there. And so texturing this thing is going to be really interesting. So the other day we also added the ability to draw any arbitrary rotated rectangle and texture it according to like UV coordinates. So you kind of have like this information. And between those two things, we should be able to build this Bezier, like build a hose out of a Bezier curve, out of segments of rotated rectangles that we can then texture according to its like X position along the long thing, right? So you can kind of imagine you have like this pattern, and then you just kind of like map that onto a curved surface, right? That's kind of the idea. And so, yeah, that's the plan for today. Is we're going to try to figure out how to generate this hose, how to texture it, and then how to make it like automatically move for like to the correct spot, right? So, um, I think the plan of action for today is it's easier to work outside of this simulation right now because there's no like control in the simulation, right? So what we have right now is we have this kind of like demo app that we're working with here, where we have like something we can pull the Bezier curve handles around, we can draw a rotated rect. And so I think like the first step is going to make like a textured hose. But then once we have the hose, I think that would be nice to kind of like have the hose kind of follow the mouse around. We can kind of figure out rules for what makes good tracking, and then we can experiment with that. Then we can like make some sort of like sucking animation, right? So you can imagine that like when the hose turns on, we might want like particles that kind of like move into towards the hose or something. We can do something like that. And then once we have something that we're happy with, we can try to like integrate with the real WebAssembly chamber. Or sorry, with the real like global simulation. So that's the plan for the day. That's the plan. Let's just kind of jump in and figure out what we want to do. So off stream, I kind of we took some rotated rectangle handling code from a previous project and tried to integrate it, and that wasn't really that clean. So I did a slight rewrite of it, but following the same concepts. So we can look at graphics Zig. We can find the rotated rectangle code handling. So basically what this does is it figures out how the rectangle is rotated. It finds like the UV coordinates for that thing. And then it basically, let's see. Sorry, the UV coordinates is was a little bit of a tangent. So say you have like a rectangle like this, right? What it does is it finds like the positions of each corner after rotating by basically finding the UV chords and projecting the corners onto these new things, right? So we know that like the height of this thing is like 0.5 or whatever, and this is like 1.0 or whatever. It doesn't really matter, right? So we can take like the width and project it onto the u vector, and the height and project it onto the v vector. Then we can find like these corners. Then we can say, I'm going to basically walk this left edge and this right edge and draw scan lines between them. And then we like kind of like map back the UV coordinates as we go. So we have that ability. When we render our Bezier curve, we break our we let's see, Bezier curve. if we look it up on Wikipedia, we'll probably find a little bit of a better animation. So we essentially do this, right? So we have like control points, and we interpolate between them, kind of tracking where on the curve this like center point comes from. So what we do is we like kind of sample this logic at like some frequency and generate line segments or rotated rectangle segments based off of that. And so what we should be able to do is we should be able to pass in a texturer to this thing that makes it look kind of like it's let's just like visualize kind of the individual line segments, and then from there we should be able to like find some sort of texture space that makes sense. Off-topic QF suggestion: you can assign a key comma to launching apps. Might make sense to have one for color paint because you will launch it all the time. Yeah, that's true. I do that a lot. So do we have our little mango thing here? No. Okay, we'll just call this like we'll make a new texture. So the way that we have this set up is that we pass in a struct for each render that like says, given this x and y coordinate in UV space, like unrotated space, what do you want to draw? And so I think I haven't checked this, but I hope that the compiler is smart enough that if we are just to return a constant value from this thing, it knows how to like inline that to avoid the like extreme penalty of doing a function call per pixel. But if it doesn't, then it's fine. We'll figure something out later. But let's make one of these. So we'll call this like I don't know what I'll call it, like gradient. And we're just going to make it so that we return alpha full. Then we will add in the x position as the red value and the y position as the g value. And so I think you can do something like hold on. It's something like x times 255. And this is going to be a u32 is equal to this. Int from float, it's supposed to be int from float. And then the g value is going to be the same thing, but 255 shifted left by 8. And this is g, and then we should just be able to do return this plus r plus g. We should also maybe clamp, or because sometimes the like x and y values can get a little bit over or a little bit below 1.0. So we might want to clamp those. So we can maybe say like if x is above 1.0 or x is below 0, or y is above 1.0 or y is below 0, we just return like the pixel that we see underneath. Basically just don't color anything. And now we should be able to say, when we render our Bezier curve, use this gradient thing. The low bits of g are not necessarily 0, no? Yeah, that's a good point. That's a good point. I'll allow it. I'll allow it. So we'll do it this way instead. You're right. And then I think we do here. This is where we've been doing this. exe. Here we go. So now we can just keep this all in one window, I guess. Hold on, just let me get out of this state. Okay, here. So now we refresh this, and we can see something of interest here. So we see all of our line segments kind of textured with their UV coordinates. And so I think the first step here is probably to try to make this one large gradient. And if you look at this, what's kind of interesting here is that like the sizes of these things are not consistent, even though we're kind of walking the curve using how do I say this? Walking the curve using like constant intervals of like this like this like interpolation parameter. It turns out that does not result in like spatial like consistency, or not consistency, like constant spatial movement. I don't know how to say it. Right, this rectangle's bigger. And so I think what we probably want to do is we probably want to like add up all of the widths of all of these rectangles, and then kind of attribute how much of the total width is part of this individual rectangle. So we could do something like, probably what makes sense is the texture object that we pass in to the render Bezier thing. It makes sense for this to kind of take in normalized coordinates 0 to 1 for the whole curve. And then here, when we render our rotated rectangle, we should, how do I say this? We should like map the coordinate space. So we can say like texture, UV modifier. And this is going to kind of follow the same API that we were using. Oopsies, index zig, not index y-zone. Follow the same API that we used just for our gradient maker. And here we're going to have to just do something like have like an inner thing, which is going to be type of texture. And what else is he gonna have? He's gonna have his like multiplier and offset. And he's just then gonna call self inner. We are only modifying x, so y is just gonna pass through. Old px is just gonna pass through. And we just have to say that the x is equal to x plus offset times multiplier. I think it's add then multiply. I think. We can think about this a little bit. So if we have like we are trying to do this segment, we're gonna have this offset and this length. So sorry. So this is mapped 0 to 1. And we want to change this to be mapped to like 0.3 to 0.5. Right? So we know that the width is 0.2. So it's actually the other way around. We want to multiply first, right? So then we can say that the range of this thing is 0.2, then add whatever our offset is, which is going to be 0.3 here. So we're going to say we're going to store the start of this as well as its width, and then we go backwards from here. Yes. Okay, so now for each of these things, we're going to have to figure out basically how much it contributes to the entire thing, which we don't know until we've walked all the points, which we have done up here. But we haven't really like kind of like paired the points up yet. So maybe we'll just do this. We'll just say this is a little silly, but I'm fine with it for now. We're gonna say var total width is equal to 0.0. Yeah, it's fine. This is fine. Then we go through each of these points and we just kind of calculate the distance between them. So it says we subtract this and we take its length. And then we just say total width plus equals that. Okay. So now for each of these, we can create a UV modifier that is a UV modifier with mul is equal to rect width over total width. And his offset is going to be traversed width. That sounds right to me. So here we can say that the traversed width is a F32 here, and then our traversed width plus equals rect width. Then here we pass in the UV modifier, and here our inner is the texture. I'm pretty worried that this is not going to be correctly, like reasonably optimized out by the compiler, but that's okay. That is okay. This should be return self inner get. Okay, so that runs, and let's just see if we have something that makes sense to us. It is very hard to tell. It is very hard to tell. I don't really see any red or yellow anywhere. I kind of just see green all over the place. But it's also hard to tell because I think that the space is very non-linear. Let's try doing something like maybe our texture, instead of using like that gradient, we can just kind of like try to mark. Maybe we'll do like a sine wave or something. I like that. I like that. So we can look at index zig, and here we can just do something like sine x times math pi times 10. I don't know. Doesn't really matter. This is going to be our red value, and then this is going to be a U32, so we have to int from float. And this we're going to multiply by 255. Yeah. Yeah. I probably have to build, huh? It's an important part. And so it doesn't really look like that we did this right. We are still seeing some like pretty heavy stretching of this. Right here, this is like really fat, so I don't really understand why. I thought this would work. So let's just do the math here. So here we're going from 0 to 1. Okay, we do, like, let's say at 1.0, we multiply by however much we have over the total width. Okay, so like, say this is like 0.1 of the entire thing. This will be 0.1. Then we add that to like where we started. So nothing about that seems, oh. We could write multiply and divide at the right time. Okay, that feels a lot better. That feels pretty goddamn good. Let's increase the frequency by like a fuck ton. Like 100 maybe? That looks pretty reasonable. And then I guess if we want it to feel like an accordion, we almost want it so that like the frequency of this depends on like the length of the curve. So, which I think it does actually. Yeah, they get more spaced out as we pull. So maybe that's okay. I also want to change it so that it's maybe like thresholded. So we'll do something like you know, if this is like below the value of like 0. Negative, or if it's above 0.9, I don't know. Then we can say, basically, if it's above 0.9, we return black. Otherwise, we return like gray or white. How does that look? That's not too bad. Yeah, let's just change the color a little bit. So, like, I don't know, 8. Yeah. Sure, fuck it. I don't really like how it feels like more things are coming in. Maybe like we don't actually want this to be UV like adjusted. Maybe like the long sections should feel more spaced out. So I wonder if we can just do like, instead of doing based off of its like percentage of width, if we do it related to its like t value. Because the t value is kind of naturally more compressed in the areas where it's curved. So can we do like struct here is like a pause 2 and t's f32, and then here we store pause equal to this and t is equal to t. Right? Here we need to store that 0.0 is a the position is equal to this, and the t value is equal to 0. And then the last point is pause equal to this, and fuck off. T is equal to 1. And then here we don't have to calculate the total width anymore. And here we do the mapping. Instead of this being the width over the total width, we can say, so these both have to say pause now. And the multiplier is going to be like, we're going to look at like the t diff is points I plus 1 t minus points I t. There we go. And so we're going to say that this is going to be the t diff here, and the offset is now going to be rect points I t. I wonder if that'll look better. Oh, it kind of does, huh? Like, in the areas where it's stretching, it like looks kind of more stretchy now, and the places where it's like compressed or look more compressed. Now it's kind of hard to see because the fucking canvas is so low resolution. But I really like the way this looks right here. That looks really fucking good to me. Yeah, it's pretty cool. Pretty cool. There's also some gaps here. I wonder if we can just fix that with like, if we just make them a little bigger. Just as a little hacky for now. Rect width times equals 1.2. Yeah, blaze it. Whatever, it doesn't really matter. It's good enough. Good enough. Did you learn Zega on the job in the past, or just on the projects? Yeah, I've never written. No, I've never written Zega work. Never. I guess these lines would look a little clearer if we made them fatter. So we could make this like maybe 0.7. And now they're, but they don't feel like they should be that fat relative to the size of the thing. So maybe we just need more resolution. Or our thing needs to be bigger. So let's kind of go back to 0.9. 8 here, 9, I don't know. 9 seems fine. And let's make the hose a little fatter. Do we have an option for that? No. It looks like our height of our rectangles is very fixed. Yeah, so this should have like a height injected into them. And then this is going to have a height like this. Did you actually use your videos? I did a little bit. I didn't like it. I edited like maybe like I tried to cut down one and I didn't like what I saw. So I then stopped working on it because I was like, I don't really want to make these videos anymore. So I don't have a need for it. I guess this is kind of called width actually. In this case, this is going to be like line width. And wherever we construct our rectangle now, we pass in the line width like this. And then when we call this thing in index zig, we should be able to, where was the line width thing? It's after the positions. So here we'll just say like 0.05. I think that sounds about right. Oh yeah, baby. Oh yeah. I'll take it. I'll take it. Okay, so we want to match the color here to what's in the rest of the vacuum. So let's pull that up somehow. Can we just like... Is this how you... Oh, fuck. Why didn't it work? Oh, because it saved it instead of fucking copying school card. Shitty default. Shitty default. Okay. Is it this? Yeah, it is. Okay. And then we need the dropper? Where's the dropper? Is there no dropper? Am I mental? I wish these... Dropper. This is a paintbrush. Oh, this is a color picker. Perfect. This is what I wanted. 0077. 77. We have to remember the number 77. There's an option that bar to copy paste instead of auto saving. Yeah, I think that's usually what I use, but I don't know why it wasn't doing it there. So, whatever. Okay, so here we want 77, which is what is that in hex? How do I get into like numerical system mode? Here we go. 4D. What did you write your first line of code? Dude, no idea. No clue. Probably like, I think in elementary school, my dad taught us Visual Basic in Microsoft Excel. I remember writing like a Hangman game in Excel during summer one time. So very young. Very young. You seem to be able to type and think at the same time. Yeah, I mean, that took a lot of effort. So when I first quit my job, like maybe August last year, I just spent a month pretending I was streaming and making sure that I was just talking all the time, which is like useful for the stream, but also it's pretty sick for interview prep. So I'm just like fucking just set for like all interviews for the rest of the time now, because now like my talking and my fingers are like very split from each other, and that allows me to like kind of talk about higher level concepts while typing up the low ones. It's just like a thing you got to practice, and it's like a sick thing to have in the toolbox, I think. Sick thing to have in the toolbox. That's close enough. Okay, let's... Interview's gonna be like, this sounds right. Fuck! yeah. I guess the practice is actually really bad in some ways, because what I have trained myself to do is not necessarily professional in any way, shape, or form. I think I want the things to be spaced out a little bit more. Let's kind of like drop this down to like 80. See if that looks any better. And let's stop this fucking thing from rotating. This is fucking stupid. So where the fuck is that happening? Step. We'll just take this out. Get the fuck out of here. Because it's annoying as fuck. Okay, so we're to like kind of like staple this on here and then try to like... It's not awful. I don't like the shitty aliasing. We almost want to like add some like lerping or something. Or not lerping, some like bilinear interpolation, I guess, is what we want. But also maybe I shouldn't care enough right this second. This is probably fine. Let's also make it Saggy-Fates' Hard Life. It's not gone. It's gone. I definitely say that a lot still. Just, I don't know if it's come up on stream in the past few days, but I definitely still say it. Okay, so kind of what I'm thinking is, I guess if we made those lines fatter, they wouldn't look so shit. Sorry, I'm just we're flip-flopping all over the place. Yeah, that does look kind of better. Okay. Yeah, so maybe what we want to do here now is like, I want a higher res vacuum. This looks really bad. I don't know if it's low res because of the image that we're importing or because of the resolution of the canvas. I suspect it's the resolution of our exported image, so let's maybe fix that as well. We can always shrink it later, but that's fucking annoying, so. Vacuum, 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 vacuum. Vacuum? Where the fuck is it? Oh, I'm in the wrong fucking folder, that's why. Open with. GIMP is fine. GIMP is fine. Oh yeah, that looks like way better. Way better. Okay, so let's export this as... where are we? We're in work. We're in Bezier Curve Editor, and we are... Maybe want to stick this in vacuum.gif. GIF. And then here, we can go back to index zig and look for vacuum. Okay, does that look better? Oh yeah, it's way better. Way better. Okay, so let's kind of just make it so that it tries. We need to find like basically what are good distant lengths for these handles. Right, because we want to have the hose have some sort of stiffness at both ends, but it doesn't need to be a lot. This kind of has to kind of this one will have to kind of rotate with where we're pointing. And this one's just going to stay fixed relative to the vacuum. So probably like something like that feels kind of good to me. Like that distance out. It gets really fucked up around like tight corners because we're rendering rectangles, and I think that we're supposed to be rendering maybe like quads, right? Like if you have a curve like this and you're rendering a rectangle here and a rectangle like here, you're like guaranteed to have this hole like this. So probably what you're supposed to do is figure out the like tangent at this point and then bring this in and these out. But I don't want to do that right now. So we're going to leave it looking like shit like that. But that's okay. That's okay. You can live with some shit every once in a while. And for us, it's every lot in a while. It's all the time. Does Zig end up replacing Rustria? Not entirely. But for the most part, for all this personal stuff, for now. Maybe use triangles, thinking. So that would look, hello, color paint? There we go. So you would do something like, you'd have to turn this into like a triangle strip. So you'd kind of have to say like, we would render this, then like, I don't know how, I have to think about it. It's almost certainly doable. Right, so you just ping pong between which edge you want to render, and then you'd have to figure out where the tip of your triangle is relative to the length. This feels relevant, the same as quads. Yeah, probably. I think so. But maybe triangles, you get the answer kind of for free. More for free. Not sure. I'll think about it. For now, I'm going to ignore this problem because I don't really want to get a rabbit hole on it again. I think I will just leave it looking like shit. Which is fine for me. Fine for me. For now, at least. Okay, so this handle looks like it's going like maybe, like if we compare this to like the size of the screen, it's maybe 0.3 maybe. If we compare it to the size of the vacuum, it's maybe 1.5 times the width of the vacuum. Maybe 1 1/3. So, okay. Here's what we're going to do. We're going to somewhere track the position of the vacuum. I think that's the first part. So let's kind of... I guess we'll just stick it in our globals for now. We'll just say we have some sort of like vacuum position. Oh, which is this already. This is probably this. It is. Okay. So the hose is going to come... we should rename this. This is going to be vacuum rect. Okay. Sure. So given the vacuum rect, the center is probably like here. So we want to go width over 2 plus height over 4. Just hand wavy. So we're going to say globals vacuum center, add x is globals vacuum rect width over 2, y is height over 4. So this is going to be the first control point of our Bezier curve. Then our end position is kind of undefined, so maybe we will still allow that side to be kind of moved around. We'll just call that B. We will just call that B. And the control point B we will still render. I don't really want to render control point 1 anymore. So control 1 is going to be basically the position of A, add, like, what do we say, the vacuum width times 1.5? Something like that. Okay. And the y is just not going to move 0. Okay. And then we'll use the control 2 and the B positions from our globals. That seems reasonable. So here, I guess when we say on mouse down, let's kind of try to get rid of the things we don't care about anymore. So globals A is gone. And control 1 is gone. So we're just using B and control 2. Okay. So now when we render our Bezier, this does not come from these. It comes from A, control, but still control 2 and B. I don't know what these lines... Fuck these lines. Okay. That feels pretty good. Pretty good. I think we just need to maybe... I think this needs to come down just a smidgen. Just a smidgen. So this is added by height over 4. So I guess if we need to go height over 5 or something, if we want to come down a little bit. Oh yeah, that looks good, baby. That looks good. Okay. So now I think what I want... Actually, let's add some definition to the hose on the corners. That'll probably help. So let's kind of do like... Where do we say dark here? Dark or equals y is greater than... I guess we'll just write or maybe we say even before we do this calculation, y is greater than 0.9 or y is less than 0.1 or this. How does that look? Oh, baby, look at that. That's slick. Maybe we need to make it even fatter. I think there's a bug where I think that we don't render the right side or the bottom side as aggressively, so maybe we'll have to fix that, but this is fine for now. We'll live with it. I'll put a fix me on it. You could fix control to b.add b add 0 minus 20. I think I think I'm gonna end up doing is I'm gonna point it towards something. So I think what's gonna happen is like it's gonna be like I want to pick up this thing here, right? And then if I like want to move it towards my mouse over here, I want it to kind of like come up like this from where it was, if that makes sense. So I think there's gonna be something about rotating. Like the end of the hose is gonna have a rotation and a position. We can add that now actually. So we can say the hose end is equal, or hose end pause is a pause too. I guess it's gonna be equal something. So we'll kind of start this at just like, it doesn't fucking matter. But if the vacuum starts at 0.5, 0.5, then the hose end will start at like 0.78, 0.3 or something. And the hose rotation is just an F32. And this is going to equal to, I guess let's have it pointing down by default. So that's going to be a clockwise rotation of stood math pi over 2. I don't know if this rotation is supposed to be clockwise or counterclockwise. Probably counterclockwise. Or sorry, I think that positive is counterclockwise is probably the convention that's going to end up being used here. So now we need to like calculate the control 2 is going to be derived from the position and the rotation in some way, right? So we're going to have like okay. Let's think about this. We are here. So this is let's say this is 0 rotation, right? We're pointing this way. We're going to take the rotation of this thing. We're going to multiply some distance back by that rotation. So we're going to have some sort of like sine theta is going to be like vec2. His x is going to be cosine of the norm, the rotation of the hose, and the y value is going to be the sine value. This is going to sum, the length of this is always going to be 1.0. And then we can just kind of like do something like control to norm dot negative some distance, right? How far back do we want this to be? We didn't really clarify. We didn't actually end up with an answer there, but let's just say like 0.1 for now. So we're going to say that the control 2 position is equal to the hose end position added with the control 2 norm with this added to it. Multiplied by this? Yeah, well, that sounds right. Yep. And then I think we're good. So here we have control 2 is now not coming from globals. This is coming through control 2 pause, and this is coming from the globals hose end position. We need to compile and run. Fuck, it doesn't work because expected type vec2, expected compound float. Right. There's no dot product needed here. Okay, so now let's try adding some rotation to that thing, and if the rotation works as expected, then we should see, like, with 0 rotation, it should point to the right and have some sort of stiffness towards the left. Which it looks like we've kind of successfully got there. This rotation feels not quite correct, to be honest. Something about this doesn't feel right to me. Just checking. Oh no, maybe that's fine. It just, maybe we need more stiffness. More stiffness. Oh yeah, there we go. There we go. I mean, that's too much, but we can always kind of dial it back a little bit. Yeah, that's probably fine. We could even go even lower, a little lower, maybe 0.2. Cool. Cool. I guess we'll see. Okay, so now let's have it like follow the mouse around and just kind of see how that feels. So how are we gonna like point it towards the mouse? Let's say that on each step, we're gonna step this thing at some frequency, and we are going to give it like a mouse X in pixel space and a mouse Y in pixel space. And on each frame, we are going to try to move the hose towards that position by some amount and rotate it towards that as well. So let's start with just position tracking. So we'll kind of say the hose end position has to trend towards this thing. So we're gonna say that we're gonna like mouse X norm is going to be 2x norm of mouse XPX. The Y norm is going to be towards Y. Oh, and we actually kind of did this. We're kind of at like 4730-ish. A little bit before this. And we also kind of did like, at some point, we did like hose, attach hose to vacuum. Okay. So here we're gonna like just trend towards this thing. So this is gonna be like sub mouse, let me think here. I guess this is just gonna be like X is equal to mouse X norm dot Y is equal to mouse Y norm. And really we could just, I mean, we could just set it to the mouse position right now. Okay, let's do this. Okay, we'll say here's how far it is. We'll say max speed is gonna be like 0.1 or something per second. Maybe a little faster. 0.5 per second. So we're gonna like say that the max speed times delta is like max dist this frame is this, right? How fast we're allowed to travel times how much time has been taken. And now we're just gonna say dist to mouse is this. Or we'll say like to mouse vector, I think makes sense. Then we can say dist to mouse squared is equal to 2 mouse vec dot length 2. I don't think that we need to square root it, so just using like the square of the length just means that you can do like less math. That's what I'm doing this way. And we're gonna say if dist if dist to mouse 2 is less than max speed 2. Here we go, max speed times max speed. Then we can just set the position. So we're just gonna say that the globals pose and pause equal to the mouse pause. And here, I guess we'll set that somewhere. Okay. This is a pause too. I don't know where I want these line breaks to be. I guess this seems fine. Mouse pause, boom. I guess this is max dist squared this frame. I'm actually not sure. Does delta need to be squared here too? Okay, fuck it. We'll just not work in squared space because I'm not sure. We'll just not work in squared space. Who fucking cares? Pre-optimizing. Okay, so if dist to mouse is less than max dist this frame, that's what we do. Here we go, perfect. Then we just set it. Otherwise, we move it towards pose and pause. Add the two mouse vec mul 1 over the length times the max speed this frame, I think. Not sure. And now we just have to adjust our index.js to basically provide the mouse position on each movement here. So can we... I guess what we should actually do is we stash it on mouse move. That makes more sense. So I guess we just have to stash our mouse position. Like this. And I guess maybe this is like null. A nullable thing. Right? Like, we only try to track if the mouse is currently over the canvas. So now we can just say mouse globals mouse pause equal to this. Oops, like this. Dun, 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 dun. And then I guess that's fine. It doesn't really matter. This doesn't really matter. D equals globals mouse pause. This is like a little duplicated, but this is also scratch code, so who fucking cares? Who fucking cares? Okay, so now we have a delta here. He is just going to move towards globals mouse pause instead. Boom, boom, boom. He doesn't like this, cannot assign to constant, so this, maybe it's like this. Right. Then here we need to basically say if globals.mouse pause is equal to null, we do nothing. Otherwise, we can assume it is set. Okay. He doesn't like this at all. He's going in the complete wrong direction. Complete wrong direction. Yeah, because we should go towards the mouse pause, huh? Not away from it. Okay. That's kind of tracking. Yeah. And then we just need to kind of like point it towards the mouse at the same time. Right, so we want to do something like max rotation is something, who fucking cares? And we are going to try to rotate it towards where the mouse is. So we're going to take like the two mouse vector we're like here, mouse is here, we have this vector. And we have like our current rotation. Right, so maybe we have like this angle. Right? We just want to kind of say, I guess we like try to figure out, do we like project this vector? We dot product this onto this. Then we have the angle between them. Kind of. If we dot product here, we get this, which is AB cos theta. How would this work when it's in a chamber? Who gets to control the hose? It's going to go towards the closest ball to the hose. So it's going to look over all the balls, say which one's closest, then move towards it. I just want to like test it in this environment first. I don't like having theta twice here. Can we call this like, we'll call this phi. So, I guess I could do this, right? If it's negative, cos big number, cosine big number, negative. Cosine small number, positive. That sounds right. So if we just normalize these two vectors, do the dot product, then we have cosine of the difference. Then we like inverse cos it to get the angle out. Yes? Is that how this works? I think so. Wolfram alpha. Let's just make sure that I'm not like fucking stupid. A cos x is x, right? No? Yes. I think so. No. Am I stupid? Am I stupid? My math is just off. I don't remember. Dude, am I fucking brain dead? Cos theta is adjacent over hypotenuse. Yes. A cos A over B is equal to theta. I'm pretty sure that's fucking right. So this has to be true. I think that the Wolfram alpha, I just wasn't asking it the right question. I'm pretty fucking sure. Oh, theta mod 2 pi. That's probably why I was trying it. Oh, that's why it looked like it was going up and down here. That makes sense. So this is linear, except for the fact that mod 2 pi. Got it. That makes sense. So we should just be able to do. So we're gonna say like 2 mouse norm is the 2 mouse vec multiplied by 1.0 over dist to mouse. Okay, so we have that. Then we just need the rotation normalized, which we have. This is gonna be like, is this stupid? Is this a stupid way of doing this? It might be. We kind of just already have this vector. So this is like our coordinates. We have like some movement. So we just take this angle minus the angle that we've already stored. Yeah, this is stupid. So we're just gonna say like const 2 mouse angle is a tan 2 2 mouse vec dot y and 2 mouse vec dot x. Fun fact here, if we use the normalized version of this, it's like guaranteed to crash. Isn't that kind of fun? Check this out. Look at this bug I found yesterday. Don't do anything on this issue tracker. But this just fucking crashes. Isn't that fun? If you just have a normalized vector and it's pointing straight up, you're like guaranteed an LVM error. So don't normalize your vectors when you're A10-2ing right now, or else you're much more likely to hit that case. Okay, so 2 mass angle is this, and we just can say globals. Okay, we have to be a little careful here. So we have like, say the mouse is, we're trying to move this way, and right now we're pointing this way. We actually need to find whether or not it's closer to go down or up. And so that's going to be something like probably you kind of like you pretend that one of these is 0. So you like subtract from one from the other and then mod 2 pi and then figure out if it's going up or down. Probably something like that. It's like 2 mouse angle minus our current angle. So that's going to be like, so this is going to be like, say this is what, I'm going to say this in degrees. So this is like 330 and this is like 45 or something. Doesn't fucking matter. We're going to get this minus this is going to be a big number, which means that we go down. Yeah. Going to and from angles or using angles at all really is sometimes considered a code smell. You could do control to norm equals normalize mouse minus hose pause. Thinking? Control to norm is equal to normalize the mouse minus the hose position. But I don't want it to always snap there, is the problem. Right, I want it to turn as like part of the movement, which is why I was thinking about working in like angle space. You could maybe store it as like a vector instead, but I don't see why you would do that. Because I think that doing that would be harder. Oh yeah, then angles might be good. Okay, good. I'm just glad I'm not crazy. So we're gonna say like, we're gonna call this like angle change is equal to this. And if angle change, and we want to kind of like mod this with math pi times 2. And then we want to say if angle change is greater than math.pi, we say, so in this case, if it's greater than this amount, we want to do math 2 pi minus that. Go the other direction. Wait a second. That doesn't sound right. Negative of this thing. Yeah. And then we'll just say clamp. The angle change now is equal to the maximum, the bigger, the smaller, minimum of the maximum rotation times the delta, or the amount of change that we have to make. I'm like not 100% about this. And then we can just say globals rotation plus equals angle change. I'm not sure. There's probably some simplifications that can be in there, but let's just kind of see where it's at first and then. It feels like the angle change is just like way too low for me to tell if this is working, so let's just kind of like ramp this the fuck up. That feels like it's working, except for when we are like really close to it. But otherwise, that feels like kind of what I was imagining. I don't understand why. I guess probably the maximum speed is just too low. It could be that I just don't want a maximum speed at all, to be honest. Oh, no, I do. That feels good. No, I think I don't want a maximum speed. I think I don't. Which means that we can just do what you said before. Let's try that. So instead of doing all of this shit, let's just ignore the rotation and just say control to norm is equal to the globals mouse pause, subtract the globals hose end pause. Normalized. I think that works. No field name sub in fine. Let's just say this thing has to be fucking fine. If yeah, fuck it. Fuck it. Let's just make this always defined. That makes my life easier for the time being. You could do some exponential approach. Yeah, I'm just not positive that I actually want it. Now that I'm seeing it like capped, the rotation capped, I'm like, I don't actually think I care. But I might. We'll see in a second. 102, so let's just ditch this. Mouse pause here as well, and here. And here. Yeah, I guess probably. So we also need to make sure that we only rotate if we're like within some distance, or like if we're far from the mouse in some way. Okay, I'm gonna go back and just cap the speed really high. Because I feel like there was something there. Like, way higher. Like... Because, like, the angle being persistent and stuff felt good in some way. Yeah, that feels pretty good. Maybe slower. I do want some limit. Yeah, that feels pretty good. I think I want it to feel stiffer at the end. And also fair and star delta time. That's probably why it feels fucked in some way. I think I do it here. Max rotation times delta. I think I do it here. I don't think there's anywhere else that needs to get clamped. Okay, cool. Cool. So let's just say that, if the mouse, I guess we just say here, if disk to mouse is less than like 0.05 or something, return. Right, because I don't like it when it's like pivoting around the mouse. What the fuck is going on? Why is it like freezing? Oh, it's freezing because it's too close to the mouse, so that number's just too big. That feels pretty damn good. That feels pretty damn good. I think I want a little more stiffness on the end. Let's try upping the stiffness. Upping the stiffness. So that's this one, I think. Yeah, I'll take it. That feels pretty goddamn good. Look at that! Isn't that sick? Isn't that sick? Oh, baby. Yeah, that's so cool. Look at that. Look at that. Oh, baby. So I'm just reveling for a second. Just a second. Just for a second. That looks so good. Oh my god. Look at that. Oh. Okay. I think I'm okay with it moving a little faster. What you want is new rote equals lerp current target 1 minus exponential lambda dt. Why? So that it doesn't like, so that there's some sort of like speed up, like some sort of like, what does x look like? Oh, it's not frame dependent. But doesn't the delta already cover that? Am I stupid? Like, here I'm like stepping at some physics frame rate, or calling it physics frame rate. Like we're stepping at some frequency, and so it's like the amount that it moves is like capped relative to that, I think. So I don't think that there's any like frame rate dependency on here. I don't think. It just like kind of like the amount that it's clamped is like linear instead of something. But I don't see why I would want my time step to be non-linear. But I might just be an idiot. It's possible. It's possible. Delta works only speed is constant. But in case of wanted minus current over 2, it's not. I see. I see. Oh well, this is fine. I'm not gonna think about it too much more. Okay, so I think that we want to maybe cap the distance from the edge of the vacuum that this is allowed to travel. Right, so we want to, so if the ball gets too far from the vacuum, we're just going to kind of move the vacuum to get closer, not the hose unconditionally. Okay, so we want to do something like we have like a max hose distance. So on each step here, wait, why is this? Oh, wait. I'm back to being confused. When you guys are saying it's taking linear steps on a nonlinear curve, that's not true if I'm saying that the rate of angle change is constant over time, right? Right? If I'm saying like I want the amount of revolutions per second to be capped, and I'm saying that like I want to move at like 2 per second. And if I'm like, okay, so I've had 0.5 seconds, so I can move 1 revolution, that's like totally linear. Right? Which is what I'm calculating here. I'm calculating like the current angle, the amount of angle change I need, and then limiting the angle change linearly. So I'm missing something, but that's okay. That's okay. I guess I don't have to understand. I think that I'm probably doing what I want to do, and you're probably suggesting something that's just better, and I'm like just not. I'm like, I don't want to do the better thing, is probably what's happening in my head. You were discussing your suggestions you're not using. Oh. Got it. I think I missed some chat messages. Okay, that makes sense. Thanks, guys. Sorry about that. Okay, mouse tracking done, and then let's do vacuum tracking. So we basically need to say that if dist to mouse is less than max dist from vacuum, we do whatever we were doing before. Otherwise, this doesn't feel quite right. This doesn't feel right. This is not what I want to track. We want like the base distance to the mouse. We want to see like from, it's gonna track the mouse here, but from here, how far am I allowed to go? Actually, fuck it. I'm not gonna clamp that. I'm just gonna say if the x of the mouse minus the vacuum. Okay. If the position of the mouse minus the vacuum rect center is greater than some amount. If this is greater than like 0.4, 0.2, we're just going to move the vacuum in that direction. So we'll say mouse to vacuum x is this. And we're just going to say globals vacuum rect center plus equals mouse to vacuum x, but clamped from negative max roll speed to max roll speed. And this has to be actually multiplied by delta. How the fuck did I just type F14? I've never seen that in my life. I must have pressed like shift or control and an F key by mistake. That's pretty funny. Max roll speed is equal to 0.7 or something. I don't know. It has to be faster than the speed of the hose, I think. Okay. I think we want it to be kind of like, actually maybe a little slower. Maybe slower than the hose and up the distance. Like we just want to be within like half a screen of the mouse. Hello. Oh, which we always will be, so maybe a quarter of the screen or a third of the screen, which was maybe what we had before. Sure. We could even have the hose go faster, to be honest. All right. You probably want to move the hose at the same rate while the vacuum is moving. Yeah, I'd be down for that. I get what you're saying. Yeah. So here we're gonna say max dist this frame plus equals the like roll amount is equal to this. And we're gonna like abs roll amount. I think that's right. I think. No, it doesn't really matter. I think that since it's always moving fast in the vacuum anyways, it doesn't make a difference. Not enough for me to do it. not enough for me to do it. I think this is fine. Okay. Looks so stupid. Looks so stupid. I don't think I'm going to do a sucking animation. I think that we are just going to try to integrate with the ball machine. I think. So, what has to be done here? What has to be done here? Sorry, I'm thinking. So we kind of need to pull the current version of Graphics Zig into our main library. God, if only I'd written commit messages that weren't just all smiley faces. That would have helped. But yeah, let's start by yoinking the latest Graphics Zig and checking where we're at in here. Okay, copy from Bezier Curve Editor Graphics Zig to here. What does that do? Adds a little bit of shit that we don't want. Adds some Bezier curve stuff that we do want. Adjust the line height. Okay, so it's just this color texture thing that we lost that we don't want to lose. So let's just kind of NVIDIA Graphics Zig. Lump animation as the balls run up it. I was considering that. But I don't want to get ahead of myself. I don't want to get ahead of myself. So it would be cool. It would be cool. For sure. Okay, let's make sure that pulling in the latest graphics thing doesn't break anything here. I don't think it should. Oh, maybe it does. Unable to load physics.zig? Right, because in this repo, physics is like a named library. Okay, chilling there. Now let's get this physics. Nope. What's it called? It's called index zig. This guy, and we also need STB image here. Just kind of weird, but we're gonna make this a new chamber. I guess we paste it like this. We name this to vacuum, and then we'll move STB image into the vacuum resources. And then from here, we also need to maybe copy the vacuum GIF itself. Okay. Okay. Now we add this to the build. We add it to the build. So we have this now gets a little vacuum from vacuum. And now surely when we build this, it will fail. Because it won't be able to find the resources because paths changed. Yep. Unable to load physics zig not found. Okay. So now we're looking for vacuum. Okay. So this comes from here now. And this is going to be, I guess in our build script, we need to say that vacuum needs to have an include path added to it, which is going to be source chambers vacuum. And we also need to add the add source file. So we need to add files could be path source chambers vacuum, and which is stb image.c. And we also have to link libc, which is a little confusing, but it doesn't actually link libc. It just lets it resolve some header only stuff that needs to get in there. I think I also need to copy Bezier curve editor stb image h also has to go here. Cool. Zig build chambers. We'll see. Maybe that's enough. Vacuum GIF not found, right, so. This is going to be vacuum resources now. Chilling, and then just undefined symbol, assert fail, so we just have to define that, I guess, which we actually had in here. Set comments up. Okay. Optimize, release, safe. Cool. Okay. So now we just have to start like moving it towards the right answer. So let's add source chambers vacuum star get status. Get add dash u, and we'll call this get commit dash m import vacuum chamber. Okay, now we can start kind of like hacking this shit up and working towards the right thing. Is this how I want to go through this? No, we did this yesterday. We don't have to do this. We can just look at like simple and start yoinking what they do. So we have to add an init function that allocates some balls from const ball is equal to physics ball. Okay. On mouse down is going away. On mouse up is going away. On mouse move is going away. Set T is going away. Canvas memory, I think, is so good. We'll kind of copy all of this stuff here. And then we just need to make sure that our step API is correct. So here, it's just like this now instead. And render. Also has to handle this. Cool. Okay. These are no longer hard-coded, which means that this is a slice of U32s that's going to be set on initialization, which we actually use down here. Okay. This needs to take in canvas height. Oh, we might not need 2 Y norm and 2 X norm anymore if we deleted all the mouse handling stuff. We don't, so we don't have to fix those. We don't have to fix those. Canvas memory comes from canvas memory like this. Boom. Did I not? Oh yeah, it's fine. It's fine. It's fine. Okay. We're not gonna touch the balls right now. I just want to kind of see if we are like rendering okay. And we're gonna call this canvas memory is equal to canvas memory from 0 to the width times the height, because it's not necessarily the whole thing. We say this canvas memory is like this, and then our graphics canvas gets this canvas memory as well as canvas width. Okay, chilling. This is not an indexable pointer because I don't have to ampersand this. Okay, and so we might be able to go into our chamber testing now and upload this thing without it being too much of a shit show. I think that we should see things get rendered, but more likely we're going to see it fall over. Because it always falls over. It's never right the first time, ever. Vacuum. Yep. What's it bitching about? Index out of bounds at render chamber, and I can't fucking see it. Right, okay. Did I not allocate this thing? Max chamber pixels, I did allocate it. So I guess we just have to start bisecting and figure out who is out of bounds. So let's do like a if true return here. And see if we at least get a line. Let's make it black instead. Oh no, it can be white because we should just actually what we can do is we can actually if true return here. Because we should see a gray canvas if this is at least like compiled and running somewhat sanely. Which you do. Okay. so that's step one. What IDE you're using? This is NeoVim. NeoVim. So immediately we are struggling to render this line, which is confusing to me. To be honest. Because this is just a horizontal line from 3 to 7. Yeah, I'm pretty surprised, actually. Pretty surprised. Because this was working, and we imported the same graphics library, so I don't really see why it shouldn't work. Let's just double check if we return here. Yeah, that's totally fine. So what the fuck is the difference? Can we try rendering, like, something really small, like dead center? Like, what am I missing? Oh yeah, that's fine. That's fine. Oh, that's fine too. I'm just misdiagnosing. Okay. Chill. We'll move down a little bit. We'll try maybe here. Maybe no good. Surprising. Is it loading the texture that's causing problems? Does kind of seem that way. Index out of bounds. Ah, so it's coming from here, kind of surprisingly. Why? I'm assuming that this will work fine. Yep. And I assume that loading from memory is what's causing our problems. Oh. Probably. It's maybe related to our, like, max memory size shit that we... Maybe our, like, build options are different here than they were before. In the other repo, add zig chamber. So we say, I want to make a WASM-exe and set WASM-exe params. Let's just disable this stack limit change thing just in case. Could be that we're running out of stack room because we're fucking idiots limiting it way too harsh. And that does seem to be related. Okay, so we'll come back to that. Because our module is going to be too large now, but we'll make it work, then fix the large issue after. So I assume that now we should be able to render our vacuum. No, really? Oh, I actually have to open the chamber. Okay, sick. So there's our vacuum. We are big chilling. Can I do, like, the whole chamber? Do I even have to, like, keep going through this process? Oh, that's so sick. Okay, let's move them down. Let's first of all set the background to white like every other canvas. Let's maybe give him a real physics surface to sit on. I actually kind of like this, like, global struct thing. We'll probably keep using this. I think I'm gonna delete these. I think nobody's using them. Render circle. Yeah, I think if we delete this, we should be good to go. Good. I meant to clear the background to white, not black, so let's fix that. Let's fix that. This should all be FF. Boom. Much better, and then we'll render our platform as white. So we have to add our platform as a... Platform is like a physics surface whose A is at x equals negative 0.1, y is equal to, sorry, positive 0.1, y is equal to 0.1, and the b is at 0.9, 0.1. For each frame, we now have to like actually like handle these balls. So we're gonna say like for 0 to num balls, ball idx. I guess that's fine, yeah. Let's maybe copy the physics handling loop from simple.zig. 2 years into computer science degree, first time seeing any of him or his language. What have I stumbled upon? You've stumbled upon some fun. I mean, I wouldn't have expected you to have seen Zig. I am surprised that you haven't seen Vim before. But, you know, everybody has a different, you know, it's just different for other people, so I get it. This is globals.platform here. Globals.platform here. And so we should see now that, like, when we render this, the balls fall and they hit the platform. Good, good. They're hitting the platform. We need to render the platform. We need to render the platform, of course, which should be as simple as typing graphics render line. Definitely surprising to not have seen Vim. Yeah, I mean, I guess if you're coming from like the Windows world, you wouldn't necessarily have seen it. So I could see it. I could see it. So here we're gonna render from globals platform A to globals platform B, and this is going to be rendered as black, which is going to be a constant of zeros. All right. So now we have a line. Things are bouncing off the line, chilling. And so now we want to put the vacuum down there. So center is like 0.2. Fuck, 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 fuck. Hello? Is it broken now? Unreachable executed? What am I fucking missing? 0.5 was fine, 0.2 is not fine? Why? 0.3? Like, hello? Oh yeah, that's fine. Okay, I don't know. I'm pretty confused about why lowering the height of the thing is a problem. Maybe it's because the hose is going off the end and we're not correctly handling that. That seems kind of possible. Seems possible. No, I don't understand. So this is coming in the rendering side of things. I mean, I guess we can start figuring it out. We can start figuring it out. So we can at least bisect if it's the Bezier curve or the sorry, brain melting. Or the rotator rect that's causing problems. I.e. the vacuum or the hose. So it does seem to be the rotator rect, huh? So rendering the vacuum rect is just... why? Is it because the height is too big? Oh, it is, huh? No, because y plus 0 minus 0.3 over 2 should be, what, like, 0.1. So it shouldn't go to bounds, and even if it did go to bounds, it shouldn't crash. But I guess we can just start trying to figure out where in here it's going wrong. Your profs are soy devs is a crazy thing to write in chat. That's wild, man. I think probably just like all devs are soy devs is probably just as correct. Okay, so if row y is less than 0 or y is greater than canvas height, that's fine. It must just be that we're doing some sort of like fucking stupid division here. I wonder if we can do our trick of trying to compile this thing as a main, like as a real executable, so we get nice little backtraces. Or we could try the trick of trying to hook up the panic handler to get console logs. I like the idea of being able to compile this thing as if it's not a WebAssembly module. So I just want to try, like, what happens if I just call render here? So we're gonna like init with like 300 by 300 or something, 209, and then render. I think it's 300 by 209. I think 208 maybe. And then max balls is gonna be 100. And then can we just try rendering with 300 by 208? Let's just see. I'm curious to see if we can make it happen. Oh, it's not easy to hook up the build system though. Oh, fuck. Okay, let's try to get the panic handler hooked up to console log. Zig, Zig, panic format handler. Like, I think that somebody linked it the other day. I just can't remember. I can't remember where it was. I remember somebody like Zig, Wasm, panic. Console log. Like, there's gotta be a way. That's Rust Wasm. I want Zig Wasm. Zig Wasm logger. Okay. But how do they hook up to the panic handler in here? Probably not. It's probably just some random guy. Fuck! I guess it's... I mean, we could just look through the standard library and see how it fucking works. It might call, like, stood log or something, so we might just have to hook up the logger. We might have to. Panic. Zig, what happens on @panic? I know, okay, let's just fucking hook up the logger and see if that does it. Because I feel like I've seen it before, and I can't place where. So if we do, like, I think it's stood options? Stood options? I think. If has stood options, we use stood options. Cool. And we set log functions. I remember seeing the fucking panic thing, though. I remember seeing a function named panic. God, this is gonna piss me off. Because I don't really see another way to, like, debug this effectively. Zig custom panic logger. Like, oh. They just make a pub function panic. All right, let's try that. Let's try that. So we should be able to just write, like, unreachable here. And then, like, use our Wasm. I'm pretty sure somewhere we have a file that has log Wasm defined in it. No? I swear I've seen it somewhere. Log Wasm, log Wasm. Huh. Okay, we'll just write it again, that's fine. I must have lost it somewhere. Extern function log Wasm takes in a const UA, pointer to a const_u8 and a len. Return expected type expression. Oh, right, and no return. Then we have a function print, which takes in a format string as a const_u8 and a args as an any type. And this is just gonna call a log wasm with some buffer and something like this. We're gonna say like we have a buff, which is gonna be 4096 U8s. And then we're gonna try to just run right into that thing. So should format buff print buff format args. Boom. So I think that should do it. And so here, like maybe we can just say print message. I don't know. Like, can we just see what that looks like, maybe? And then on init, let's also just try to print something just to make sure. Print, hello, mom. I'm on TV. Expected type this. Oh, here we have to write or else unreachable. Found this. So there's a const_u8, built-in structures, and then a usize. I don't know what that usize is, but we'll add it to the API. Okay. It's or else unreachable should be catch unreachable. Okay, and let's see if we get something useful to us now when we go to here and we go, well, so we just see reached unreachable code. Hi, mom, index out of bounds. Oh, thank God, thank God, thank God, thank God. And then we can try to get the stack trace back. So did we have an example of that guy using the stack trace here? So you just said this. All right, sure. So this unable to stack trace dumping not implemented for WASM. That sucks. But at least it's slightly more helpful. At least it tells us where it fucking like what the error is. That's a big win for us. So it's index out of bounds. 45843 length. So it's got to be like rendering the rectangle. It must just be going out of bounds of the canvas. So we can check that by saying print canvas size is canvas len here. No, that's not it. Oh, I wonder if it's sampling in our texture sampler. If we are fucking up, we're fucking up our sampling here. It could be here. So we could go print this number. Aha! Aha! So it's when we're trying to sample from the vacuum image, we are going out of bounds. Okay. So here, these guys must be just going. I don't understand how it's possible. Oh, this is probably greater than or equal to. Probably. Probably just some very, very slight out of bounds indexing. Refresh, please. There we go. We got there. We got there. So depending on where the vacuum ends up sitting, just the texture sampling became like very slightly different, and that was causing very slight issues. Okay, fine. Fine. I deserve it. I deserve it. Now let's run to the hose. Chilling. And now I guess the hose is a little too far to the right. So we increase that number a little bit to get it to get a little snugly in there. There we go. And then he's sitting a little low, but that'll be fixed when he starts trending towards the ball. So I think first let's make it so that the ground, when it stuff bounces off the ground, it has to kind of like get stuck there. So let's like lower the elasticity of the ground a little bit to try to get stuff to like kind of like, yeah, get stuck there. And then we also want to apply some friction, which we don't have like as part of our default physics library, but it's pretty easy to do. So we can just say that the ball x velocity dot x times equals, you know, some slowdown factor. Sick. Okay, so now everything gets stuck on the ground. And then all we have to do is start like rolling around. Panic to find here if you're still interested. I'm curious. Because I found somebody implement the function, but that's clever. That's clever. So the piece I was missing here is that I should have been looking at built in. So if I go into like const built in is equal to import built in, and I jump to this, I can look for panic. No? Is it in standard library? Okay. Interesting. So that like how would, if I wasn't attached to the standard library, how would it know? This is confusing to me because I thought that Zig is supposed to work fine without the standard library. Oh, but this is types and values provided by the language. Okay, so there's some sort of like some sort of attachment there. I see. I thought that the standard library was completely optional, but maybe even though it's completely optional, those things are still like hooked in by the runtime. Oh, I guess. No, I'm missing something. You can just not use it and it won't compile. I see. I see. Okay. So somewhere we kind of have to target which ball we want to walk towards. So instead of going towards the mouse position here, we want to kind of work towards the closest ball. So we're going to say like closest ball index is 0 or something, and closest ball dist is going to be a float, I guess. And this is going to be like std math float max for an F32. We're going to like iterate over all the balls, which we're already doing up here. We can just like compare where they are to the hose end. So var globals hose end pause. And we can compare this to the ball. So sub ball pause. And length, I guess. We can say that the ball dist is this. And if ball dist is less than closest ball dist, we set the closest ball index to I and the closest ball dist to dist. Chillin'. Which means that now down here we have the closest ball. We can say the closest ball pause is closest ball this, so balls at this. Yep. I guess here we have to make sure that this is if num balls is equal to 0, we can't do anything here. And then here, this is now related to closest ball pause for both here and here. So anywhere that was trying to look for the mouse before just looks for the closest ball. Chillin'. Chillin'. No thing named sub here because it was supposed to be balls dot pause like this. And okay, so we do see it kind of snapping to a ball now, which is pretty sick. And then I think what I'm gonna do for now is kind of just teleport the ball into like how do we want to do this? For now, let's pretend that the vacuum is in like push mode. That feels like it'll make sense. So instead of sucking the thing up, it will just apply an impulse to the ball in whatever direction it's facing. So here, we will just say that the ball's closest ball index velocity is equal to the closest ball is this. And here the closest ball velocity is just going to have its going to be its velocity, yep, plus wherever, like somewhere we have like the angle of the hose. But I guess it's just here. We don't actually have it as a vector. So we can just say that the hose and normal is equal to a vec2. His x position is the cosine of hose and rotation, and the y is the sine of this thing, and then we just add the hose and norm multiplied by like some speed, right? Oops, wrong one. It's not working. It's not working. What if we make it like way bigger? What the fuck? What the fuck? Let's print and say setting velocity. Why isn't it moving? Why isn't it moving? It's fine. Play. He's just never pushing it, which I don't understand. Hose end pause is equal to the closest ball pause. Like, surely. Or here we'll say not close enough. Firefox crashed? Fuck. That's annoying. I hope my stream doesn't die. No, because the stream is not attached to Firefox. That's good. But chat is. Poor chat. You guys are completely alone in the world now. Completely alone. Why does it check the distance to the mouse? Because I want it to like... well, because by mouse I mean ball. I think. Disk to mouse is to mouse. Yeah, it's just because we had everything about mouse is turned into ball now, but it should be fine. And then we're trying to only push it if it's close by. We could do some sort of like exponential fall off or something, but I think this is fine. Okay, and we go back here to spheroforia.dev, and hopefully it doesn't fucking crash me this time. So here he's just still thinks he's not close enough. Oh, but then he stops printing. He's not printing, he's not close enough anymore. Oh. I see. So this needs to happen. Disk to mouse? No, I don't see. Ah, here it is. Here it is. So maybe we'll just do it here instead. So we can just do it. Whoop. Oh, oops, and we should still return there. And then probably this is gonna like accelerate it just like in the fucking middle of nowhere, but we'll just see if it at least does something. That's kind of funny. Okay, there's all sorts of like fucking stupid problems with this. It looks so fucking stupid. Oh man, that's pretty fucking sick though. Not gonna lie. Not gonna lie. That's so awesome, actually. I'm actually like so happy with that. Oh man. Oh, okay. Okay, so those get so stretched on the left side. Oh my god. Okay, so let's at least make it so that the where it tries to move the vacuum closer to the ball, it should be relative to the right side of the vacuum. So this is actually going to be like the hose start position, which we calculate somewhere. But I don't want to figure it out right now, so I'm just going to add the width over 2. So this is going to be the closest ball as plus, I guess, another minus here. Yeah, I think that's right. There we go. At least it like tries to move to the left now if it needs to. What graphics library are you using? Missed a lot. This is like our own graphics library. Our own graphics library. So we wrote this kind of like over the course of the past few days, in an attempt to make this work. Needs to go upwards a bit, but maybe other than that, great. Yeah, it would be kind of nice if it like the hose like hooked under, huh? Okay. I mean, oh, dude, that's so sick. Okay, I actually wanted to go give it a little bit of a harder push, just like really fuck shit up. So where is that applied? It's this like, if it's here. So let's like maybe multiply by 4. Okay. I also want to limit. There's something here that it's moving too quick on, and I just don't know what it is. Like sometimes it just like kind of like teleports backwards, which I feel like it shouldn't do. But maybe that's a result of like the way the Bezier curve is handling it, or maybe it's the rotation speed needs to be limited, like way more. Like if I limit to this like 5 instead of 10. It still feels like super fucked. Okay. Anyways, that's really close to what I was looking for. I think that this is like a fucking hilarious and awesome chamber as is. So I'll probably try to clean it up a little bit, but I'm really actually really pleased with where we managed to get so far. So I think I'm gonna call it there for today. Thanks for watching, guys. If you like what you saw, we stream most days at around 12:30 to 4 Pacific time. So 12:30 to 2 is kind of like cleanup, kind of vibing, kind of like small tasks that don't really deserve their own stream. And then like 2 to 4 is kind of like the more focused, trying to get like one feature done type of thing. I think that I'm going to try to say that this is going to be like, I'm hoping that this is the last ball machine stream. I think that I will probably still work on this a little bit more in like the pre-stream section, because I kind of want to get to the point where I can kind of have the simulation kind of sitting here, and we need to add more chambers. We need to make sure that like users who are uploading, if you guys want to upload them, you can, and we need to make sure that we like accept those. But I think I want to move on to something else for the mainstream. So for the mainstream, I think I'm going to move on to working on like a path planner to help me bus around the system city better. So I'm kind of pissed off at Google Maps for thinking that I don't know how to walk. Like if I'm like, hey, I want to take the train downtown, it goes like, surely you don't want to take the train because you have to walk 10 minutes to get there. Surely you want to take this bus ride that's like 3 times as long. And it kind of pisses me off that like everything does that. So I'm gonna be looking at that probably starting tomorrow. But the ball machine is not done. We're just gonna kind of like keep working on that kind of on the side. If you're new here, there's a YouTube link and a GitHub link in the Twitch description. So VODs go up onto YouTube for the mainstream. GitHub should have code for most of these projects. And there's a Discord link there as well if you want like announcements and kind of like updates on stuff. So if I'm like oh, I'm gonna go live today at this time, sometimes it goes up there. Sometimes I'll be like, hey guys, like we're live on this site if you want to go check that out. So if you want to go there, that's where I post. What else? I think that's it. YouTube, let's say goodbye, and Twitch, let's find someone to raid.